Hello everyone. My name is Sharad Chandran. I'm a principal product manager with the Oracle Data Access team. And welcome to my current presentation, where I will talk about connection pooling and multiplexing for performance and scalability in Oracle database. So in this session, we will take a sneak peek of the database server process models, including something we call DRCP or database resident connection pooling. Then we will dive in to a bit more specifics of DRCP, which is the main focus of our topic here. Then we will look at how to configure DRCP on both the database side and the application side, along with some optimization attributes. We will look at what views can be used to monitor this DRCP connections. Finally, we will round off an example with DRCP. So for connection pooling and multiplexing, we have this great feature that we call DRCP, which we will talk about in detail. But before that, to start off, let's take a look at how applications use database connections. Now, database connections are pipelines from the application to the database that allow the application user to access and work with data. So consider this scenario for a particular Oracle database environment. In the beginning, you have a single standalone connection from an application. So this connection establishes a dedicated session with the database with the it does its work using the database resources like session memory, server process, etc. The application holds the connection and the associated session resources till it is explicitly released by the application itself or when the application ends. Now, meanwhile, other connections from other applications or the same application will come in, whether it be from a client pool, which we will talk about later, or from other standalone connections. So this will fill the number of connections available in the database and puts pressure on the memory of and resources of the database. Now, what if the database connection quota is full and another connection comes in, and now the earlier connections are still active? So the database will deny the connection for the app, or the database itself may fail. So this is not ideal for real world architecture or applications when a lot of concurrent connection comes in. So how can you make your database scale up then? You can use something called as the shared servers or multi-threaded servers or MTS. Now let us run the same scenario that we did with the dedicated database servers. So as you can see here, in this case, a middleman process called dispatcher handles the incoming load and allocates the database server process to a connection using a queue in the system global area of Oracle database. So system global area is the global memory area of Oracle database, which is common to all the database server processes. So the connection from the queue will get served by the shared servers one by one, and the database resources are not stressed as much compared to the dedicated servers, because we are multiplexing the database server processes over the incoming connection request. Now, the new connection, let's consider what happens when a new connection comes in. So when a new connection comes in, it will wait for a shared server in a separate queue in the system global area. And the session information, note that the session information lies in the system global area as well, which means the session memory is still not multiplexed. So while this shared server or MTS may be useful for architectures with a moderate level of concurrent connections, it may not be suitable for architectures with high concurrency. This is because the idle connections will still hold the database resource and the session memory. So it will not be suitable for the high concurrency architectures, because the session memory will increase in the SGA area as the number of concurrent open client connection increases. So what do we do for high traffic mid-tier architectures? Well, you have something called as the DRCP or DRCP pool servers. So DRCP stands for database resident connection pooling. DRCP enables sharing of database processes and session memory across the middle tiers on both the same and different hosts. So fewer database resources are needed to support fewer database resources are needed to support a large number of client connections. So this reduces the database tier memory footprint, and it boosts the scalability for the middle tier as well as the database tiers. So basically, the more the database resources are shared, the higher the scalability of the overall architecture. Now let's take a sidebar here and take a look at something called as the application side connection pooling. So if you notice in the earlier slide, in addition to the standalone connections coming in from the application, you will also see connection pools in the application. So the reason is standalone connections provide an open close behavior and are expensive to scale up. So because each use of the standalone connection will involve authentication, creating a database server process, waking up the network listener, allocating the session memory, and then finally destroying the process. So there is a additional time cost for all these setup and destroying scenarios. So most apps which handle multiple users will use a connection pool for better performance. So this connection pool will remain open till the application ends. So generally, you use a pool if you need a lot of concurrent connection for short periods, that is pool on the application side. If you have a small number of connections that are often idle and can be timed out by the application pool, and if you want to get more scalability from the application side. So having talked about application side connection pooling, we will now move on to the most scalable pooling option that we have in Oracle database, which is DRCP. So DRCP, like I said, stands for Database Resident Connection Pooling, and it has been around from Oracle Database version 11G onwards. It is available in all editions of Oracle Database and is usable on premises and in Oracle Cloud. So what does DRCP comprise of? It basically is a server-side pool of dedicated processes called pool servers, which is a combination of both database server processes and database sessions. So this pool server can be shared across applications running on the same or different hosts, and it is particularly useful for multi-process or multi-server clients which are unable to fully share their connections on the client tier. So we always recommend that DRCP should be used with application side connection pool, and it is extremely important to note that DRCP is highly scalable. It is capable of supporting tens of thousands of the database connections even on a commodity box. So it is definitely useful for highly concurrent connection traffic and app tier users. And DRCP is supported on the app side by different Oracle database drivers such as OCI, OCCI, which is Oracle C-based libraries for accessing Oracle database. You have JDBC, you have Python drivers, Node drivers. So all these drivers support DRCP or database resident connection pooling. So let's talk about the database architecture now. So the database architecture plays a vital role in achieving this high scalability of DRCP. So initially, DRCP has a set of free pooled server processes, which avoids the overhead of allocating a dedicated server for every client connection that comes in and requires the server for a short amount of time. So applications will generally request connections from DRCP by communicating with a background process known as connection broker, that you see on the screen. So there can be multiple connection brokers as well, or a single connection broker, which can be load balanced. And the connection broker will multiplex the pooled server process on the database side among the inbound connection requests from the clients or applications. And to first, the connection broker will authenticate the connection request by using a reserved set of processes from this same DRCP pool called authentication servers that you see on the left of the DRCP server pool. And a server process, and around 5% of this current pool servers are reserved for authentication. Now, a server process from the free pool will become active when they are selected by the connection broker and connected to the client for the database activities. Once the database activities are completed, the server pool is returned, the free active server pool is returned back to the free pool, and the client or the application will establish a link back to the connection broker. So this link will remain open until the client process stops running or another client request comes in. Also, in case of DRCP, the session memory is stored in the program global area of the database, which is physically private to the process. So you can contrast this with shared servers where the session memory was stored in the SGA. So this particular implementation will enable the client to reestablish a connection quickly when any database activity is required. Now let's look at the DRCP operation. So with DRCP, the database listener initially hands the new connection request from the client to the DRCP connection broker. The connection request must initially be authenticated by the authentication servers before running any database transactions. The broker gets the authentication done using the authentication servers and this will be triggered when there is a log on or log off from the application. So once the authentication is done, then the broker keeps the client connection persistent till the client either closes the connection or till the client requests for a database activity. So further pooled server requests and releases will happen on this persistent and authenticated connection and are coordinated by the connection broker. So on a session request for a database activity, the connection broker assigns a server from the free pool of server process for the client, and it hands over the authenticated client connection to this server. So the client now will carry all the database interactions on this assigned server process, which is referred to as the busy server over here. So once the database transactions are done, the server gets ready for release, and it is released back to the free pool, and the session is handed back to the connection broker. So generally, the client closes the connection explicitly through an API call or when the application ends. So once the BC server is released back to the free pool, the client will restore its connection back to the connection broker. And like I said earlier, the connection broker will hold the connection either till a new connection request comes in from the client or when the application ends. Now, looking at let's look at the various scenarios or architectures when DRCP will be useful or essential. So first, whenever there is a heavy client connection load with support required for minimum memory usage on the database, we use DRCP. DRCP is useful for applications when connections are held only for a short duration, and for large scale deployments with several app servers and mid-tiers that require database access. Also, architectures with app servers that cannot execute mid-tier connection pools, like say PHP app servers. In this case, the DRCP support is essential. And DRCP is useful in apps that mostly use the same database credentials for all database connections, and also in apps which have identical connections in terms of their session settings, that is in terms of their date formats, for example, or their PLSQL package state, etc. Now that we have looked at all these three database server process models, let us compare the memory usage on the database. Now consider a total of 5,000 application users connecting to the Oracle database for one particular architecture on a 64-bit OS, which is running your Oracle database. The memory required for each database server process could be 8 MB, and the memory required for each session would be 400 KB. So in all, the dedicated server process would consume 42 GB. Now this drastically reduces when you look at shared servers. So in shared servers, let's say you are using 100 shared servers. So in that case, the memory drops down to 2.8 GB. And in case of DRCP, the memory drops down even further because the session memory is also now shared. So it drops down to even 1 GB. And the DRCP uses 35 KB per connection for its connection broker as well. So you can clearly see that when there is a large requirement, DRCP pool server provides the best database host memory usage among the three options. So let's look at how DRCP is configured. So initially, when Oracle introduced the multi-tenant model with container database and pluggable database in Oracle 12c, DRCP could only be configured and managed by the CDB, which is a container database, and the PDBs can only access the CDB level DRCP. This has been the case until 21c, but in 21c, DRCP configuration comes with two options now for the Oracle Database Administrator or DBA. The first is the aforementioned CDB level DRCP, which is the default mode. And the second is the per PDB DRCP, where the DRCP is created, configured, and managed for each PDB. So the general architecture is you have a single CDB and you have multiple PDBs. So now for each PDB, you can set the DRCP. So to enable this per PDB DRCP, you need to set the database initialization parameter called enable per PDB DRCP equal to true. And note that in the case of per PDB DRCP, the PDB admins will manage the per PDB DRCP. Whereas in the earlier CDB level DRCP, the CDB root user, which is basically the sys user or any user with sys DBA privileges, who will manage and configure the CDB DRCP. So let's look at configuring DRCP. Now, right off the bat, when you bring up an Oracle Cloud Autonomous Database, DRCP is enabled by default. So the database administrator does not have to do anything. And the Oracle database and the database administrator user will not be allowed to start, stop, or even configure the DRCP feature. But for non-cloud Oracle databases, the first choice that the DBA has to make is to see if the database DRCP configuration is per PDB DRCP or CDB DRCP. Now, for this example, I am going to take a CDB level DRCP. So in this case, only a database administrator with sysdba privileges will be able to start or stop the pool. In the case of per PDB DRCP, the PDB administrator with execute privileges on a package called dbms underscore connection underscore pool, which is a standard PLSQL package. So only he or she will be able to start or stop the pool. So here we are using the start pool method of the dbms connection pool PLSQL package to start the DRCP pool. Next, to stop the DRCP pool, you use the stop pool method within the same package. You can also configure various inbuilt parameters of DRCP using the configure pool method of the same PLSQL package dbms underscore connection underscore pool. For example, you can configure the minimum number of connections, the maximum number of connections, the various timeouts for each connection, whether it be inactivity or think time, in one go using the configure pool method. So, but in this case, you have to give all the parameters, inbuilt parameters of DRCP. If you want to configure only certain parameters of DRCP, you can use the alter param method. And if you want to restore the default config values of DRCP, you use the restore defaults method. And now we have seen for CDB level DRCP, in per PDB DRCP, like I said earlier, the PDB admin will execute the above commands for each individual PDBs. So now more DRCP optimization is possible through setting some other parameters on the database side, which are the database initialization parameters. So we have already talked about enable per PDB DRCP. You can also configure the maximum and minimum number of authentication servers that we discussed about using the maxauth servers and the minauth servers DB initialization parameters. The DRCP dedicated optimization is an optimization parameter which can be set by us. It is by default set to no, but it can be set to ensure that the DRCP connection works like a dedicated server connection. In the dedicated server connection is more optimized. So you can make it more optimized as much as possible. And also you have DRCP connection limit, which basically sets the number of DRCP connections for a PDB that is allowed. And the final database initialization parameter is the connection broker parameter. So connection brokers will set the number of connection brokers, the connection broker types, and the maximum number of connections per each connection broker that is allowed. However, note that the connection brokers cannot be set by the PDB admin. Even when per PDB DRCP is enabled, it should be set at the CDB level. Now, we have talked about the DRCP settings on the database side. Now, what about the application side? So in application side, once everything is set on the database side, you just need to set the connect string to use DRCP. So you can set the connect string using the EC connect string that you probably know. So you can set the :pooled string at the end of the database service name to ensure that it connects through the application connects through DRCP. Or if you're using a TNS connect string from any network configuration files like tnsnames.ora, then you can use the server equal to pooled method that or the parameter that you see over here to ensure that the application connects through DRCP. Now this connect string is usually set during the pool creation or connection creation functions in an application, which we will see later. So next up, I just wanted to discuss a few other optimization parameters from the application side that you can set. So generally, DRCP will guarantee that the sessions in the DRCP pool servers cannot be shared across multiple database users. However, DRCP also additionally gives you the option to further partition your pooled server process into logical groups called connection classes. So DRCP sessions with the same connection class can be shared across multiple app process or other applications, and it adds an extra level of sharing boundary. for the applications which use the same DB user and service name. So the same DB user can have multiple connection classes and for different suite of applications, and their all the data and session information is private to these suite of applications. So I'll explain more about this in an example in the following slide. Note that the connection class can be set using the create pool method or the function for pool creation or connection creation method, and it can be set in the connect string as well. And also the other parameter that I want to talk about is the purity parameter. So purity basically controls the reusability of the pool sessions in DRCP. So it has two values, self and new. So in the case of self, you can set the self value if you want the application logic to reuse a pool session. So this way you don't have to create a session again and again and go through the process of building up and tearing down the connections that we talked about. Or if you want, you can still use a brand new session every time when you set the new value for the purity. Again, similar to connection class, it can be set in the connect string, or it can be set during the purity can be set during the pool creation or the connection creation functions. So here is an example of a connection class grouping. So for the same user Scott, applications in a group called sales may be willing only to share pool servers between themselves, but not with a different application group called CRM and so on. So now you have a separate connection class for the sales suite of applications and a separate connection class for the CRM suite of applications. This way, the sales applications using Scott as the DB user will not leak any session information and can set up effective boundaries with respect to CRM applications or other applications that use Scott as the DB user. So this works both ways. CRM applications will also not leak their session information to other applications. Now, next we'll move on to see how Oracle database can monitor the DRCP connections. So you have inbuilt data dictionary and dynamic performance views which are available in Oracle database, which will monitor the performance of DRCP. So basically you can check statistics like number of busy and free servers in the DRCP pool and number of hits and misses in the pool against the total number of client requests. So you have the DBA cpool info view, which displays configuration information about the DRCP pool, such as pool status, maximum and minimum number of applications. Then you have the different dynamic performance views. So these performance views will display the DRCP pool statistics for a database instance. So whatever pools have the word CC in them, they are specific to a connection class. So they display connection class related information and mapping of this connection class to various DRCP pools. So we will be using $cpool_cc_stats in the upcoming example now that you see. So finally, we come to this session. We come to the section where we discuss about example using DRCP. So for this, I have created a demo table where there are two columns. The first column is the ID, where the number is generated by default as and when rows are added. The second column is the username, and I have inserted one user called Sharad, which is my name. So let's look at the app that we are going to use. So we are going to use the Python we are going to use the Python Flask app. The reason is we are using the Flask framework is that it will create a simple web app which we can correlate with the real world web apps that we have. So to start off, what we do is we import all the required packages and do the required settings. Then we use the Then we use the create pool method, which is used for the application side connection pool that is created. So we set the user credentials and everything in this create pool method, and we do not hard code them. We get it as a user input. So it is always recommended not to hard code your user credentials. You can use external authentication like LDAP and Kerberos if required. Now the parameter that you see highlighted over here called server type equal to pool will ensure that the application will connect through DRCP, which I mentioned earlier. Of course, you can use the EC connect string or the TNS names in the service underscore name parameter that you see to the left of server type, again to connect through DRCP, but this is another way. And next, you can also see that we have set the connection class and we have set the purity as self by default. So the default value, even if you don't set the purity, it will be self only. But I've set it anyway just for completeness. Now that now that we have done this, let's look at the other sections of the code that we have for this app. So here we are specifying some routes, which are basically parts of the URL string used to do some function on the URL, such as post or get data. So if you see here, the slash user slash ID that you give will be given on the browser to access the user with this particular user ID. So let's say you want to access the username with user ID 1, you have to give slash user slash 1 in the web browser, along with the along with the server name and the port name, which you will come to shortly. So here we have added the route to access the username through the user ID. Similarly, you can also add routes to insert data into the demo table, which I'm not going to show here, but it is quite simple. Um, Next, the final part of this code is to initialize the Flask session. So this particular code will bring up the Flask web server in the local host, and where the port number is 8082. So now we will run the Flask app by setting the user credentials in the run environment. This is a Python application, so I run it using Python. And then I enter the username, the password for this particular user. And now the app server has started on my local host and in 8082 port. So basically it will show up like this on the right hand side of the screen. Now, in addition to running it one time, I also downloaded the Apache benchmarking tool, and I ran around 100 requests on accessing the user ID 1. So I should get Sharad 100 times. Now, the Apache benchmarking tool also collects various statistics about the requests that we have run on the web server app. So note that the time taken here is 0.453 seconds. And when we look at the $C pool underscore CC underscore stat, it gives you the number of hits and misses. The number of hits it says is 100. That means the hit ratio is, sorry, there is a typo here. The hit ratio is high here. Why is that? Because the purity is set to self. So when the purity is set to self, all the data is set only once, and the remaining data is cached on the database, and the building up of the database and the SQL plan is not required again and again, because it is stored as a cache on the database. That is why the hit ratio is high, and the time taken is 0.453. Now, if I want to change the purity to new for some reason, you will see the difference. You will see that the time taken is more. It's 0.769 seconds. And also if you look at the $C pool underscore CC stats view, dynamic view, the number of misses have increased and the number of hits have decreased, or it has remained almost the same. Basically, the hit ratio has reduced. Why is that? This is because we are recreating the session request with all its data, bringing up the database server, creating the session data, etc. again and again. So this is primarily because we are setting the purity equal to new. So the recommendation is that do not change the purity to new unless it is absolutely necessary. So this, and there are many other parameters in the other views and the dynamic dictionary views that I talked about earlier that you can use to monitor the various performance aspects of DRCP. You can experiment with different languages as well. Please do check out our DRCP technical brief, which I can provide later, which is available freely on the net now, where you can see how you can use DRCP in various other languages. And with that, I have come to the end of this presentation. I hope this information about DRCP and our connection pooling and multiplexing methods was useful. And with that, I would like to thank one and all for attending this session. In case of any doubts, please do feel free to contact us at this email ID that you see over here. Thank you for listening.